Our third speaker, Vasilis, is from Stanford University. He's going to talk about class clustering for hiring modeling in work marketplaces. Thank you.
Hello, everyone. This is a joint work with Panagiotis, Papadimitriou, Ramesh, Johari, and Hector Garcia-Molina, and it took place at oDesk Research. oDesk is a large online work marketplace, and it was recently renamed to Upwork. I guess most of you know exactly what I mean by the term work marketplace, but let me just go very briefly with a description of what a work marketplace is for those that haven't heard the term before. So in those marketplaces, a client comes in, he asks for a job that he wants to perform, then some freelancers apply for this job, and they ask for a specific amount of money to complete the job. Usually, what happens next is that the client will go with interviews with a few of them that he will select, and then he will pick just one or a couple of them to perform the task. And the number of applicants for each task it can be from tens to hundreds of applicants. So it's very important for the marketplace to help the client with this process of picking the right freelancer for the job. The impact of those recommendations that the marketplace makes can be in the order of tens or hundreds of thousands of dollars when the project is something very big, or when the client is a new client that he's willing to start a business using freelancers from the marketplace. So as I said before, the marketplace will help the client by ranking those applications and presenting the applications in the rank order. And the most straightforward approach to do that is to use past applications and past clients' decisions and use those past applications and decisions as a training set to learn a model. So we can have each application will be an example. We can have features like the score of the freelancer, which is based on the reviews of clients for past jobs, the moment that the freelancer applies, the skills of the freelancer and how they overlap with the skills required for the job, the asking amount, and many other pieces of information that can form the features for each example. The positive examples are the applications that were accepted, and the negative examples are the applications that were rejected. So in this toy example that I have here, its application, we only have two features: the experience of the freelancer that he's applying on the y-axis, and the price that he's asking on the x-axis. And we can train a model, something like a logistic regression, a linear model that will give us a hyperplane W0 here. Then for a new job, when the applications will arrive, given by the green cycles here, we will compute the distance to the hyperplane. We will also take into account on which side of the hyperplane they lie, and we will rank the applications based on this distance. So there are two main issues with this straightforward approach. The first issue is that not all clients have the same hiring criteria. So we cannot really have a single model for all clients. For example, there are some clients that are very hands-on. So they want contractors that they can contact every day. They will see the samples from their job, and they will see that they are on the right track with what they are implementing. There are other clients that are hands-off. They just want to give the description of the job, and the next time that they will contact the freelancer, it should be when the job is completed. The second main issue is that we consider all hires as positive examples. And in practice, there are some hires that end up in a very bad experience for both the client and the freelancer. And usually it's because it wasn't a good hire. The decision of the client was not the right decision. So the framework that we propose for resolving these two issues has as a main component a clustering component that will cluster clients into different groups so that in each group, clients have the same hiring criteria. And we will train a model for ranking the applications for those clients in each of these clusters. And then there is another component that will monitor those collaborations that take place in each group. And then if we are confident enough that some of these hiring criteria are causing unsuccessful collaborations, we can go and intervene semi-automatically or manually and adjust the models. And there is also another component that will assign new clients for whom we don't have any information, we don't have any past decisions. We will just see the little amount of information we have, and we will try to assign them to a pre-existing group. So in this work, we just focus on this clustering component of the framework. So in the rest of the talk, I will give a more formal definition of the problem. I will describe you the algorithm that we developed, and I will just shortly describe some of the characteristics that we found in the clusters generated by our algorithm. So the input to the problem is all the past decisions, all the past applications for clients. Again, I'm using the same toy example I was using before. And what we want is to split those clients into clusters so that their decisions are as well separated as possible. I don't know if it's clear here, but the training samples from the second cluster and the training samples from the first cluster, if we put them together, they will give you the picture that we see on the left plot. So in this toy example, you can see that we have clients of two types. The first type of clients are quality optimizers. They just care about the experience of the freelancer. They don't care about the price. In the second cluster, we have clients that just care about the price. They want the cheapest freelancer possible, in a sense. In the paper, you will find a more formal definition, a very clean and simple definition of this problem, where we essentially define the maximum likelihood splitting of clients, assuming that their decisions can be explained using a logit model. So the algorithm is also a very simple expectation maximization algorithm. It starts with a random assignment of clients to clusters. And then in subsequent steps, it will learn a single model for its cluster of clients. And then it will reassign clients based on which cluster better explains their decisions. And this loop will go on until it will converge to an optimum. Now, the problem is non-convex, so this optimum is just a local optimum. And we need to repeat this process a couple of times to find the best local optimum that we can find. And the output of the algorithm will be the clusters of clients, along with a single model for ranking the applications for each cluster of clients. So in the evaluation, we used a data set of almost 900,000 applications over a 7-month period in Upwork, oDesk back then. And we had two main objectives. The first objective was to quantify what's the improvement if we use this client clustering approach compared to just having a single model for ranking applications for all clients. And the second objective was to analyze the clusters that the algorithm produced and see what are the differences in the hiring criteria of the clients. So here I will just give you a glimpse of the analysis on the clusters and the differences we saw in the hiring criteria of clients. And in the paper you can find the other parts of the evaluation where we compare with a single model, and we also have a third part in the evaluation where we study the baseline behavior of the algorithm using synthetic data. So here you can see in this plot, I think it's a little bit small, the font here. So you can see what are the weights for 4 features using sparse logistic regression when we train a single model for all clients. And these are the weights for the same 4 features. These are the most interesting features that I have here. When we apply our clustering approach, and I just have 3 clusters here that are the most interesting clusters. There are a number of interesting points. One is that the weights are very different for we're comparing the clusters with the model for all clients. The second interesting thing is that in the second cluster, you can see that clients heavily rely on this feature, which is the matched skills feature. This feature quantifies what's the overlap of the skills of the contractor with the skills required for the job. And while in the first cluster, clients, they rely more on the contractor score. This is a score produced by reviews from clients for the past jobs that the freelancer performed. So we can find an explanation why there is such a big difference in those 2 weights between the first and the second cluster. In the second cluster, there are a lot of IT jobs. There are 2 main types of jobs in Upwork. The first one is IT jobs, jobs like web development or search engine optimization. And the second is KPO, which stands for knowledge processing outsourcing. And we have tasks like translation, logo design, marketing. So the IT jobs are usually more complicated. And in a sense, the clients tend to give very high scores. They tend to respect the effort of an engineer to perform those tasks. So this contractor score that is based on past reviews is not a powerful signal. A more powerful signal is how good the skills of the contractor match with the skills required for the job. On the other hand, in the first cluster, we have a large percentage of KPO, almost 80% KPO tasks. And these tasks are simpler, and usually the reviews are capture better how consistent the freelancer is, and if he indeed deliver the outcome that the client was expecting. The third cluster, one of the main differences when comparing to the first 2 clusters is that this feature, which is the contractor's total hours, and it reflects what's the amount of work that the contractor has in the platform. This has a large negative weight, and this is because we cannot find an explanation by looking at the characteristics of the data in this cluster. These are just clients that they want to work with freelancers that are very new in the platform, and there's a very good reason for working with those freelancers because they are eager to build reputation in the system, and usually when they are skillful, their first tasks have a very high quality outcome. So to wrap up, in this work we focused on clustering clients based on their hiring criteria, and if there is a main takeaway from this talk, it should be that in those domains, we need to find the differences between the hiring criteria of different users. We need to monitor the collaborations that take place and intervene in order to improve the matching of the clients with the freelancers and have more successful collaborations. Thank you.
Any questions?
question on your clustering algorithm.
Yes.
You have to specify the number of clusters you want?
That's a really good point. So this is an input to the algorithm, really. And you need to do something to find what's the right number of clusters, right? So if you have too many clusters, then you won't have enough data points in each cluster. So this is a problem. If you have a few clusters, it may not be the real clusters that take place in your data set. So one way is to use, because you cannot, it's very difficult to compare what's the outcome, the quality of your solution in terms of precision and recall, where you have 2 clusters and when you have a different number of clusters, 4, let's say. So you need to go and see on the same testing set, to go and see, or in a different testing set, to go and see what's the outcome for a metric like mean average precision, and see how well it ranks your, how well you rank your applications for solutions that are using different numbers of clusters. That's a very good point.
Any more questions?
Thank you. So I have one comment and one question. Mm-hmm. So for the 3 clusters, I was thinking maybe the last cluster is maybe some kind of abuse of the system, because the newcomers maybe just try to hire some people to hire himself to build a reputation. Because it's very common on e-commerce. So you know. Yeah. Maybe, I don't know. You can check it out.
Yeah, this is to be honest, I haven't thought this way, but because I've opened, as a client, I've opened a lot of tasks. I had really good experiences with freelancers that were new in the platform. I'm a hands-on client, so I want to usually those people, they want to contact you again and again and show you samples. And so usually, for me, it worked really well. I think I would be in this cluster of clients. So I think there are a lot of freelancers that are trying to build a reputation. But yeah, this is a really good point, yeah.
Okay. Yeah. The question is that, did you really look at the clusters to understand which cluster are price-driven, which cluster are quality-driven, and if the quality and precision recall for each cluster is different or roughly the same?
So yeah, this is also a really good point. So I don't think for most of the runs we didn't see like the image I had in my toy example where we had cost optimizers and quality optimizers. Usually, because they are bidding, freelancers are bidding, they tend to adjust, and that's my feeling about what happens. They tend to adjust, and even the very good ones, there's not a large deviation from what they are asking. They are usually very close, the amount of. So this is maybe an explanation on the second question, which is about how much the precision and recall deviates from cluster to cluster. I have some numbers that to be honest, I don't remember. There were some cases that there was some interesting deviation. So in this run, for example, we have 500 clients, and they are split it in some of the clusters that are like 1/3 of the largest cluster. And maybe in those cases there is also some interesting deviation in the precision and recall. Yeah.
The last question.
I'm wondering if you consider clustering on the basis of task type rather than client.
So so there is already some segmentation of the market in terms of a taxonomy of the tasks. So how would it be used in this case?
So as I look at your diagram that you have up there, the big difference between the clients seems to be on the basis of tasks.
Yes,
so I wonder if task itself is a better clustering
I see. So you are
dimension.
saying, or something like a hybrid, right? Like having a different clustering for IT jobs and a different clustering for KP. Yeah, this is a very interesting direction to also take into account this taxonomy and see. Of course, we should always take into account that as we keep splitting and applying something in a smaller region of the data, we have much less training samples to work with. Yeah.
Perhaps you can answer Cyril.
Yes,
Oh, sorry. Yeah, just a quick question.
I think, obviously, one of the principles we're doing those sort of things is you can either do mathematical models or simply ask a question to the clients. Do you think, obviously, you've done the hard work in terms of clustering your client's requirement? Do you think you can replace your clustering algorithm just with a simple question in the client?
Can you specify what the approach?
Sure. Obviously, you identify the clients' clusters based on quality and price sensitivity. That's the main criteria to separate your different clients. So do you think you can replace this cluster algorithm running your overall framework with a simple question of, say, whether you focus on price?
I see. So find the hiring criteria by actively asking the clients what
Absolutely.
they do. That's the question, right? Yeah, this is also interesting to, like in a sense, sometimes clients do not really understand why they hire someone. They don't really know why this is. So we also trying to find out what are the things they are looking for in a client. And I guess the whole idea is to try to involve the client as less as possible in this process. Already going over interviews with many of the freelancers it has a lot of friction, and one of the main purposes of this ranking is to help the clients do as less work as possible with finding someone to do the job. Yeah.
Cautious of time, we have to move on now. Please join me to thank Vasilis again. Thank you.
Thank you.